So, hello. I think we have Play CVR on YouTube, and I think there's one person on Twitch. Hello to them. So today, hopefully you can see and hear me okay. I'm trying out streaming from home. Previously, I'd been streaming from my dad's office. That was because my internet was previously not able to upload fast enough to do streams, but I've since got in mobile broadband or cell broadband that has better upload than my fixed line broadband, so we're gonna try it out. So in this stream we're going to take a look at controlling a 12 volt light strip using an ESP8266. If you don't know what an ESP8266 is, it is a wireless Arduino. It costs about $3, and yeah, I think they're pretty cool. You can do pretty much everything you can do with a regular Arduino with them, and then you also get the Wi-Fi built in as well, so that's a nice touch. Okay, so let's get started. So I'll probably be streaming for about an hour, so we'll see how far we get with it. So the first thing that I have here is a 12 volt white LED strip. I bought a 5 meter length. It was about $5 delivered from AliExpress, and I've just cut off what I needed of it. So where I'm going to put these is under my kitchen counter. Let me just give you hello. I forgot to add my face to the proceedings. Hello, Mark, on YouTube. Thanks for joining in. Let me know if you can't hear me or anything like that. This is my first time streaming at home, so I don't know if the quality will be good or if it drops or anything like that. Just let me know. I'll see what I can do. Yep, so this is an already cut piece of strip. It came with just two loose wires, a black and a red one at the end of it. So I've already attached a piece. So this is a 2.1 millimeter barrel socket. That's my only one of those. But to show you what that looked like when it wasn't all taped up, it was basically like this. So it has two little terminal blocks at the end that you can screw into, and so instead this is the male version of it, so that's the female. So if you can, oops, I took away OBS from myself. So yeah, so it looks like that, except it's the female version, and then it plugs into a regular 2.1 millimeter socket. So yep, that's handy. And this is a 12 volt 2 amp power supply that I also got on AliExpress. I got it by mistake because I bought a 9 volt 1 amp power supply and they sent me a 12 volt 2 amp power supply, so I guess can't really complain too much. My Twitch stream health seems to be pretty poor, so hopefully it's not as bad in person as that graph looks. Mark is asking, how long do I wait for stuff on AliExpress? It kind of varies, Mark. Around Christmas time it's really slow. Really slow. Maybe like 2 months, 3 months maybe. During the summer it's maybe 2-3 weeks, maybe 4, but I've noticed it started to get slow again. So yeah, if you need stuff for Christmas, you'd want to be buying it now. So yep, this is my 12 volt 2 amp power supply. I didn't bother opening a dispute with him because the 12 volt 2 amp power supply was useful. So I'm just going to plug that in and show you what these LEDs look like with full brightness. very bright. So that might be too bright. So what we're going to do is we are going to use the Arduino or the ESP8266 to do something called PWM. If you looked at my live stream on the creating the Wi-Fi controlled car, we also used PWM for that as well. So basically what it does is it turns on and off the signal really quickly. So so it gives kind of like an average voltage that is lower than, say, the 12 volts that this strip takes. So if you had it on like that'd be quite a high duty cycle basically, so that would be still pretty bright. But if you had it so that it was low most of the time and then on just for a little bit, low most of the time, on for a little bit, that would be pretty dim. And you do that in the Arduino environment. You do that in the Arduino environment using analog write. Hello to Klep Taco. I see you say it lags a bit sometimes. Okay, yeah, I can see if you dropped frames in OBS. Like, as I said, I'm on cell broadband, so it's probably not the most stable. Maybe the next, if it gets really bad, I can try restart the stream with like lower settings. So let me know if it's a problem, and thanks for letting me know. Maybe in the next time I'll start off with something lower. Okay. Maybe if I get rid of my face as well, it won't. Maybe I move too much. I'll just make myself smaller. I don't really, Mark. I don't use my account at all. Mark is asking if I have Facebook. I haven't really used my account in maybe 4 years. I still actually have an account, but yeah. So the other thing I want to try do is I want to try power the Arduino off the same power supply as the LED. So this is a DC to DC voltage converter. So I think maybe the first thing that we'll do is do that part of things where we'll power the Arduino using the 12 volt power supply. So an ESP8266 is a 3.3 volt chip, but the Wemos has a 3.3 volt regulator, so it can take 5 volts in as well. So we're not going to use the board with the male headers, we'll use a breadboard. So let me get rid of these, I don't really need them. Okay, so the first thing we're going to need is a way of yes, Klep Taco. These streams they'll be saved on YouTube, and they'll also be on Twitch if you want to catch them up that way either. This one should be pretty short. I'm only going to stream till maybe 11 o'clock my time, which is like 50 minutes. So yeah, you can definitely catch back up, and if you have any questions, just leave a comment on the video. Okie dokie. So yeah, we're going to use this. This is just a 2.1 millimeter socket. So let's just plug this out for the minute. But so you can plug that in there, and I just have already I've already soldered just regular DuPont jumper cables onto the back of it, and so that lets me plug that into my breadboard. So there we go, 12 volts in the breadboard. So I think maybe the first thing to do would be to measure that is actually 12 volts. So I'll get out my multimeter. Because this DC to DC converter is adjustable, I might move you in a small bit closer actually, and let me now focus you. The DC to DC converter is adjustable using the potentiometer here. So we're going to need to hook up the multimeter anyways to make sure that our output is good. There's 2 viewers on Twitch. Hello to both of you. And Mark is saying, can we chat online when the... maybe. What do you mean, like on Discord or something? I don't often have time to do that sort of stuff, but sure, we can see. Okay. Now, I am going to use these special cables I've made up. So there's an alligator clip on one end. Sorry, I haven't focused you yet. 1 second. And there we go. Okay, so there's an alligator clip on one end, and then I have soldered a DuPont cable the other. So this is very handy for when you want to work with something on a breadboard that doesn't normally connect to a breadboard, such as a multimeter. So I've got 2 of them. So I'm plugging one into the ground line on my breadboard, which I'll connect to my black terminal or probe on my multimeter, and then I'll connect the other one to the red. So we'll switch my multimeter to voltage mode, and we'll turn on the light. That did nothing whatsoever. So I'm going to plug in the 12 volts, and yep. Okay. So yeah, so that that is shown 12 volts, so we can work with that. Yeah, so Mark is asking, do I use Restream for your ESP8266? No, Restream is a service that lets you stream to one place, and then it restreams your stream to multiple different places. So I'm streaming on YouTube and Twitch at the same time. Yeah, I'll probably revisit that Facebook counter someday, Mark. I didn't like the way you need to generate a long token or something. I think I read online afterwards that you could generate a permanent token, which would be a much better solution. If you look on Instructables, some other people have made Facebook counters that use a permanent token, so it might be a good idea to check that out. I haven't actually looked at that Facebook project pretty much since I made the video and wrote the Instructable, so it's been a while. Okay, so this DC to DC converter has an in and an out, and I've already soldered cables to it to make it just a little bit quicker. So I'm going to plug my negative of my in into the negative line, positive of my in into the positive line, and let's move that closer up here. Oops. Okay, and now we are going to put the output of it into the other side. So what we're going to do now is we're going to connect our multimeter to the output, plug this back in. So we got our little blue light. So you can see here that the output's reading 3.3 volts. I've obviously already adjusted this for ESP8266, but I am going to adjust it to 5 volts just in case there's anything I want to run on 5 volts. Because of the regulator, it'll drop it down to 3.3 volts if I connect 5 volts to the 5 volt pin. So I'm going to just adjust the potentiometer. So I'm just twisting it till I get to my 5 volts. A little bit too far past it. And not too bad. I'm very bad at this game. Okay. Maybe my multimeter's slow. I'll blame that. That's close enough. Okay. So that's we now have 5 volts on the bottom rail here too. So we're done with the multimeter for a minute. 1 second, I need jumper cables. One problem I have with jumper cables is you only get so many black and red ones, and you use them more than anything. Andreas Spice had a good trick where he started using blue ones for black and orange ones for red as well. So that's a pretty good idea, I think. So I'm just going to plug out the power supply while I plug it in. So that's 5 volts connected, 5 volt pin, and ground connected to ground, hopefully. So I have a blink sketch. No, I don't have a blink sketch. I had a blink sketch running on the ESP. That was the one with the female pins though. So let me just let me do a blink sketch. So I have it connected up to my computer. I'm using COM port 3, and I will upload. So that'll just take a second while we're waiting. Health seems okay on Twitch. Had a big dip there a few seconds ago, but seems alright again. Hello to whoever the one viewer is on Twitch. And what do we have? We have got, I don't know how I check on Facebook or on YouTube, but hello to you too, whoever's on YouTube. Okay, so blink sketch is running there. You can see it, but at the moment it's plugged into USB. So if I plug out USB, switch back to main desk with me. So we'll connect up the 5 volts. Okay, so we've got our blink sketch running. So the next thing I would like to try do is power the lights at the same time. Make sure that there's no flickering or anything like that, that the power supply is able to keep up with both, I guess. So I am just going to grab something to plug into this socket. Yeah, one really nice thing from about streaming at home as opposed to my dad's office. My dad's office is much better internet, but it took me a long time to set up. Every time I wanted to stream, like it'd take me like nearly an hour to set up every time. So it was really slow progress, and then I would also have to take it all down again after the hour. So it was not fun from that perspective. They were fun to stream though, and there is something nice about having 20 meg upload broadband, which mightn't sound a lot to some of you, but my fixed wired broadband here at home has an upload of 0.4 of a meg. So normally I get between kind of 1.5 and 2 on the mobile broadband, so that's a big improvement at least. Okay, so after connecting up my wires that I had been using for the multimeter to these two wires that are connected to a regular 2.1 millimeter jack. So we're going to plug that in there. And also, just to make sure that they don't cross, I'm just going to tape them, or blue tack them, just so that they're not moving around, that they're pretty fixed now. So there's a nice shine off the ESP there. Let me just move that. Okay. So hopefully when we plug this in, we see the blinking light on the ESP8266, and we see a nice solid light on the LED. And we do. Yep. I don't see any problems with that. All you can see is a big bright light down in the corner. Yeah. So let me try the Restream chat. So I can see multiple streams at once. Okay, so hopefully when people do chat now, that it'll show up in the Restream window. That's another nice thing about streaming at home. I have more monitors, so that's always a good thing. Okay, let's see. Right, next we want to, so in order to control the power going to this LED strip, we can't just use the pin of the Arduino or the ESP8266 to power it, because it needs 12 volts, and the Arduino pin wouldn't be able to supply enough current anyways. So what we're able to do is we use something called a MOSFET. So that's basically just like a big transistor that's able to handle a lot of current, and we're going to plug that in. And so what we do is we use the Arduino to turn on and off the MOSFET, which will connect the power to the LED strip. So instead of controlling the LED strip directly, we're controlling the MOSFET, which in turn controls the LED strip. So I'll show you a little bit more what I mean about that now. So I've got my collection of MOSFETs here. I think it's the IRL-B8721 that I need to use. So I'll grab that. And there is a guide that I keep going back to on Adafruit's website every time I want to do this. So we'll jump into that. Adafruit. LED MOSFET. Yes, usage of RGB LED strips. So I think this is a really nice, easy guide to follow. Ooh, I don't like how slow that is. Maybe my broadband is struggling. YouTube is claiming the health of the stream is mostly good. Twitch has not been happy over the last while. I don't think I'm giving anything away by showing you my dashboard, but as you can see, that's very, very up and down. Okie dokie. Right, where is... Yes, I need this back. Okay, so they show a wiring diagram here. So they're using a TIP 120. So that would probably be good enough for my that might be pretty good. So I have the two of them that they mention here. For basic low cost usage, we suggest using the N-channel MOSFET, such as the blah 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 IRL8721. These are very popular and inexpensive and work with 3.3 volts and 5 volt logic. If you can't get those TIP 120, are also good, but there is more voltage loss in the transistor than in a MOSFET, which is why we suggest using those first. So less heat loss, more light. So yep, the IRLB8721, which is this guy, is what we want to use. So we're just going to plug him into the breadboard. So if we look, I lost my mouse. If we look at, let's turn off my voltmeter. So if we look at this diagram here, so this is an RGB strip. The one I'm using isn't, it's just a regular white LED strip. So I only have two pins that I need to control. So it's like I'm using, I have a 12 volt pin and I've got one pin. So I can just concentrate on the 12 volt pin and the green channel of this diagram. I can just ignore the red and the blue. I don't need it at all. So that is fine. Okay. Oops, I clicked on something I wasn't meant to. So as you can see here, they just connect the left leg of the MOSFET. Okay, so what are they doing here? This diagram shows the NPN transistors, such as the TIP 120. Yeah, okay, so this is the MOSFETs and this is the transistors. So we can just connect them straight up. We don't need any resistors or anything like that. So it's very similar to the, do they have it here? Sorry, here it is. The diagram shows connecting up with N-channel MOSFETs where the gate is pin 1. So that's the gate, it's connected to the Arduino. Drain is pin 2, so that's connected to the output, so that's ground of the LED strip. And then the source is going to be just our plain ground is connected to the last pin. So we can do that now. So again, we get some jumper cables. So we don't need to do anything with the 12 volt pin. He's already connected and looks fine. So we'll move back to desktop again. So the 12 volt pin is already connected the whole way through. That's no problem. But what we're going to do is we're going to move the ground pin. So the ground pin is connected to the drain of the MOSFET, which is the second pin. So I'll just make sure I have that connected in. Right, yep. So that's fine. And now we need to connect ground to, or the source pin of the MOSFET to ground. So I'll plug that in this side and plug it into ground up the top here. And then the last thing we need to do is connect up to the MOSFET, the gate pin, to the ESP8266. So we're running a blink sketch on it at the moment. So the built-in LED is connected to pin D4 of a Wemos. So if I just connect to the, if I connect the D4 at the moment now, we should see our LED strip blinking at the opposite way of the built-in LED. So when the LED is on, the strip will be off, and then the other way around. That's because the built-in LED is active low instead of active high, which this will be. The LED strip will be. So that's connected to D4. So hopefully perfect. Works out exactly as planned. Okay, cool. Oh, it might be a good idea actually to record this too. Next one I'll do that. So at least the recording will be of good quality. I could upload that to YouTube directly, so it doesn't have the issues with streaming. Ooh, see, it's gotten very bad now, and it's picked up again. Okay, cool. So, okay, the next thing we need to do is probably write some code. We'll try out analog write so we can not blind you every time we turn this on. So let's switch over to my desktop. Okay, cool. So this is, and we'll move away from the built-in LED pin actually as well. So I'm going to move to D2, just so we're not blinking the onboard LED anymore. So what I'll do here is hash define LED strip, and I'll put that on pin D2. Right, so we get our LED strip. A couple of new people have joined on Twitch. Hello to ye. I have the restream chat open and I haven't seen any new comments on YouTube or anything. Maybe I'll just reload that page, make sure that it's up to date, because sometimes I find it stops tracking new messages. No, all quiet on that front. Okay, cool. Let's do this, right. Okay, so we've connected the MOSFET to pin D2 now, and so we're going to use that to control the LED rather than what we were using before, which was just happened to be D4, because D4 is the same as this LED built in, and I was too lazy to put a new sketch on it. Okay, so I'm doing LED strip as D2. I'm setting that pin as an output. So this is just the basic blink sketch that comes with the ESP examples. So examples ESP8266 blink. And yep, so LED strip. So low is fine, that's when it's off. And then it's delayed for 1 second. And now instead of doing a digital write, we are going to do an analog write. So the syntax for analog write is the pin, which we need to do this, LED strip. So the pin is LED strip, and instead of high, we pass it a number. So with more regular Arduino boards, I actually covered this in my last video, quirks of working with the ESP8266. It's on my YouTube channel. Basically, with regular Arduinos, the max number that this can be is 255, but with ESP8266's, the max number can be is 1023. So if you put in 255, you think you're going to the max, you're actually only going to a quarter brightness. So I know that can catch some people out. So what we'll try here is set it to 200. So that should be pretty dim. It should be like less than a quarter brightness. So hopefully that's good enough. I need to save it as something. I'll save it as LED strip. Okay, cool. So what we're doing at the moment is we're just doing basic control of the LED strip, but what we want to eventually do is be able to control it using our phones or even through Alexa, and also I want it to be controlled using rotary encoder. So like even if the Wi-Fi is down or whatever, that this spinning this will still make it brighter or darker, and pressing the button will turn it off. But then I want to also be able to control it using my phone and Alexa, as I was saying. So, but as is very important for all Arduino projects, you want to start small. So you want to get the different components working. So I wanted to power the board using the same power supply as the LED strips. That was the first thing I got working. Then I wanted to make sure that I could control the LED strip at all using the Arduino, so I have that working now. So we're kind of building on it every time. So we had the simple version of the LED strip just turning on and off, and now we want to see about you know, using it brighter or dimmer or whatever we want to do. So yeah, that would be my top tip with doing Arduino projects. So another thing actually that I covered in that video that I mentioned, the quirks of working with the ESP8266, is there's a bug in the ESP core, the 2.3 released one, that basically this would work with a normal Arduino, that I've analog written here to this pin, and then when I digital write, that would make the pin low again. That doesn't work with an ESP8266. I actually need to analog write 0 before I can digital write to it again. And at that stage, I actually don't need this one anymore because I've already written 0 to it. I'll leave it in for the moment, but that's definitely something that caught me out before. So with a regular Arduino, if once you do a digital write, it'll completely remove the analog write. That doesn't work with the ESP8266 with the current released version, but it's fixed in the release candidate version for 2.4. So hopefully whenever that's released, this won't be a problem anymore. Okay, cool. Right, so let's upload this, and while we're doing that, I can check on the chats. Okay. YouTube, all quiet. Twitch, we're up to 4 viewers. Hello, Twitch viewers. If you have any questions on anything I have covered or not covered so far, please let me know. Even if it's not directly related to this project, if it's something I can answer while working on this project, I'd be happy to try it. So I got an upload memory failed, and failed to open on COM4 because I do not have my USB cable plugged in. So I'll plug that in. Make sure I've got the right port selected, and I do, and upload. Okie dokie. Yeah, so previously when I was streaming in my dad's office, I always kind of felt like I had to do like a pretty big project and get it finished. So with streaming from home, I don't feel like that needs to be as much, because as I was saying, there was so much effort into setting up the stream. Like I had to bring in my computer and bring in my lights and cameras and everything. Which sounds more fancy than it is. This is my my lighting setup, but and then the camera mount for the overhead one. Yeah, it took a while to set up, so yeah, I wasn't gonna go in and do an hour stream, that's for sure. So yep. Okay, so that's uploaded. I do not have the main power supply plugged in, so that's why the LED strip isn't coming on, I hope. Yeah, so yeah, I can definitely notice it in real life, and I think it's pretty obvious on camera too that this is way dimmer than it used to be. So that's good. Connor on YouTube, did I get better internet? I did, sort of. I am using that 3 mobile broadband bringing you this live stream, so if it's choppy, blame them, but the fact that it works at all, you can also thank them. So yeah, it seems to be working okay. Maybe I'd say the next time I might drop down the quality a little bit more, because I do see it kind of going up and down. But yep, that's better than it was when I just had regular broadband. Okay, so I think the next thing that I want to do with this is maybe get the rotary encoder working. So basically what this is it's a digital kind of dial, so it doesn't have a limit. It looks like a potentiometer, which is like a variable resistor, but a potentiometer, you'll reach the end of it, and it'll, you know, stop. But this kind of provides an indication that it's been turned right or left, you know, anti-clockwise or clockwise. It doesn't have a limit. You could spin it forever in one direction. So what's nice about that is it gives us full control over the brightness of the LED strip without kind of having something physical limiting the LED strip. So if we want to do like Wi-Fi control as well as the rotary encoder, you know, they can both just be adjusting a variable on that's contained on the ESP8266. It doesn't need to be, you know, something physical. So let's get that working. I haven't worked with them a huge amount, but we'll get it going. I've used it once before, but these terrible Chinese breadboards. Try down here. Kind of have a problem if I plug it in down there because I can't get at the pins. So okay, I'm gonna plug out my power supply. So this I know for sure that it takes two. It takes ground, obviously, and it takes like VCC voltage. So I'm gonna plug 3.3 volts into it. Let me go back to the overhead main desk with me. Okay, so the pin furthest here is ground, so I'm gonna connect that to ground. So I am going to connect it down to this ground. I'm pretty sure both grounds should be the same, but just in case they're not, they should be connected to each other. They must be actually in order for it to work. So I can go back up to the top. That'll make it easier for me. And then I need to connect the next pin in is plus voltage. If I have another rotary encoder, it might be easier to show you what I'm doing with it. I do. So I've connected ground to ground. The next one is plus, so let's connect that to 3.3 volts. So plug the pin in here. Try plug the pin in here. Terrible breadboard is stopping me. Okay, that's plugged in. That's plugged into 3.3 volts. The next one is switch, which I won't plug in just at the moment. That's basically you can press this in. So this will be handy as well for turning it on and off. Actually, you know what, let's plug that in. Let's get that feature working first, and then we can move on to the dimming it. Let's not use blue. Okay, so let's plug the switch into D5. Okay. Okay, so I've just connected up the two powers and I've connected the switch into D5. So let's go back to our sketch. Desktop. Okay, so we need a second pin. It is an input pin, but we might also use pull up. So pull up. I'm not sure if I need to use an input pull-up, but so basically what a pull-up does is normally with buttons you'd connect it to a pull-up or a pull-down resistor. So you connect one side of the button to say 3.3 volts and then the other side, which is the one connected to the Arduino, to make sure that that pin isn't left floating, not connected to anything, you'd connect it to ground, but through a pretty big resistor. So when the button was pressed, it would, you know, take the path of least resistance and go to the 3.3 volts rather than going to ground. But you can use a built-in pull-up resistor. I don't know if I need to use it though. Not sure. Let's ask Google. Sure, I may as well bring you with me on this journey. Rotary encoder button example. Thank you, Google, for fixing me. Reading rotary encoders. This is way too long. Let's try home mechatronics. Yes, this looks more like my baby. Thank you, Shane. He says the stream looks good on YouTube. It comes and goes, Shane. If you hang around long enough, it'll turn terrible again. AliExpress, your second most visited site. I'm surprised it's not my most visited site, to be honest. I have a problem. Okay, so he is using digital read output A. Okay, so that's for the clock. Does he have an example of the button? No, he doesn't. Hello, Johan. Yeah, guys, the new people who've joined, if you have any questions at what we're currently doing, just let me know. I can gladly recap. Still haven't found an example of this button. If I don't find one in the next link, I am just going to guess. It's not going to be a big deal either way anyways. So blah 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 blah, push button, yeah. This is way too long. How to use that push button rotary encoder. Rotary encoder requires 5 volts. Does it? I might need to use 5 volts. I don't think I do. Push button is the bounce and red, like any push button. Okay, so it's fine. So let's just connect that up to D5. Could we get a quick recap by Red? Yep, no problem. So let's move to the overhead. Desk with me. Desk with me doesn't seem to have much of me. Oops, wrong. It's big me. Okay, cool. So what we're doing here is we have a bit of a mess on our hands now, but it might be easier to actually just draw it out and then show you the mess afterwards. So we have, we're trying to control, sorry about the noise. We are controlling an LED strip. That's my lovely LED strip. A 12 volt LED strip. And we're using an ESP8266 to control it. That's my lovely ESP8266. So we're using a MOSFET, which is like a transistor that can kind of switch a lot of current, because you can't connect that directly to the ESP8266 pins to turn it on and off. We need to connect that to the ESP8266, and I can drop a link to the guide I used for that. So basically what we're doing is we're turning on and off this MOSFET, which in turn turns on and off this this LED strip. So that means that we can control much higher voltages with the low voltage ESP8266. And yeah, so on top of that as well, we have a 12 volt power supply connected to our circuit, and we wanted to power the ESP8266 using that as well. So that is using this DC to DC module. So what I did was I connected up the 12 volts and I adjusted it so that it gave 5 volts out on the far side, which is connected to the 5 volt pin of my ESP8266. And yeah, so that's pretty much it, and we can see that in action now. So we have it blinking at the moment. So you can see there it's blinking on and off. And the other thing that we did as well is we did analog write on the Arduino to make it dimmer. So if I just did a digital write, that would switch this MOSFET on all the time, and it'd make this just super bright as plugging the 12 volts directly in. But what the analog write does is it basically turns on and off this MOSFET really fast, and it does it so often that the average voltage that goes to the LED strip is lower. So this is maybe about a quarter brightness. I know that looks super bright on the camera, but it's not as bright as that in real life. To answer a couple of questions here, Connor, what's debounced? So basically debounce, Connor, is when you press a button. So say if your pin is high, when you press the button it'll go low, but it might kind of bounce when it gets down there. And what you want to do is, or even, you know, you might fat finger it yourself, or when you press it, you actually kind of press it twice. So what you need to do is maybe allow some buffer so if you consider that down, so you go, okay, I got a button press here, maybe you want to ignore the next 100 milliseconds of whatever happens on that pin, because, you know, a human probably can't click that fast, and, you know, it gets rid of whatever happens here. So, you know, if it bounced like that, maybe it would consider that you know, going high again, which would be like another press, or, you know, whatever. So that is what debouncing is. That basically, there's hardware debouncing and software debouncing. Software debouncing is the easiest. You just basically ignore whatever happens on that pin for the next 100 milliseconds. Red to Fire asked, is the ESP, or isn't the ESP8266 3.3 volts? It is, but I'm using Wemos D1 Mini, and that has a built-in 3.3 volts regulator. So if I connect to the 5 volt pin, that'll get converted to 3.3 volts. I could have adjusted this voltage converter to 3.3 volts and connected to the 3.3 volt pin instead, but it's just sometimes a bit more flexible that if you also have 5 volts, just in case there is like power consumption isn't a concern for me here, because, you know, the main consumer of this will be the LED strip. Like the difference between, you know, the efficiency of the 3.3 volt regulator doesn't really matter to me because it's powered into mains. But, you know, there's some sensors that are only 5 volts, so it's good to have both voltages available to you on the board. So like I have the rotary encoder connected into the 3.3 volt pin of the ESP8266, so that's, you know, that's going through the voltage regulator. So I have 5 volts on the bar down the bottom here, and I also have 3.3 volts available to me, and I have 12 volts available to me on the pin on the top. So that is a quick recap of everything we're doing so far. Okay, so back to the desktop. Okay, so finally the encoder supply pins requires 150 ohms. So I'm using it's kind of an encoder module, so it probably already has that. So Red to Fire is saying that would have been useful when I was working on the water level monitor. The ESP8266 doesn't work, or didn't work well with the 5 volts. Yeah, I actually have a video on voltage logic levels, and the HCSR04, which is an echo sensor for everyone else. So basically it pings out how far, or pings out a noise and measures the time back and calculates the distance from that. That's the example I use because it is a 5 volt sensor, and as you mentioned, it doesn't work. ESP doesn't work too great with the 5 volts. You could damage it potentially, and the echo sensor doesn't work well at all with 3.3 volts. So yeah, now back to Arduino. Thanks for the questions, guys. It's nice to be prompted for something to talk about rather than have to try to think of something on the spot. Okay, so we can just use, sorry, let's get a pin here. So I don't know if you remember, but you helped me out with that back when you uploaded it. It actually helped. I don't specifically remember, was it on Reddit or on YouTube? It's funny, it's not like I'm this super big YouTuber that has so many comments and questions that I can't remember them all, but yeah, I don't specifically remember that. That logic level video was a good while ago. It was maybe March or February, so I can't remember. I'm getting old. Alright, so let's call this push button YouTube. Okay, cool. Well, I'm glad I was able to try help. Yeah, I think that video did pretty well. Most popular video so far has been on Wi-Fi Manager. I think it just got shared in a couple of places, and that helped the views a lot on it. But yeah, I think the logic level one is pretty handy because a few of my friends were getting into... Ooh. Okay. No, YouTube just threw up a big error saying I'm not receiving enough data, but it seems to fix itself. A few of my friends were trying to get into Arduino before, and the logic level was definitely a thing that was confusing them, as in, okay, what do I do when this is a 3.3 and that's a 5 volt or whatever? So yeah, I thought that would make a good video, so I'm glad people liked it. I still actually use it to link to people a good bit if they've questions on it, because yeah, I think it's kind of one of those things that's sort of important to know. Okay, so we got this push button input, and yeah, we're probably also going to need to have a delay. Let's call it push button, oops, push button cooldown. I don't want any of you judging me on how terrible all this is. Especially you, Connor. Okay. Alright, so instead of blinking now, what we'll do is, if we detect that the button is down, is that what we want to do? Okay, so we'll do a digital read. I can't see my keyboard, so my mic is in the way. I'm touch typing. So we're doing a digital read on the push button pin. So I think we can just do a if digital read. I'm not sure if it's going to go high or low, so let's see what happens. Do a delay here. So what I'm just going to do is, oops, pressed insert and everything. I am, oops, give me one of my other examples. Market test. Yeah, perfect. So I'm just going to bring in serial code here as well. So this is just so I can see, so I can log out from the Arduino basically. So I don't know if this is going to be normally high or normally low, so I'm going to write out high or low. High, oops. And so I put in that delay as well, just so it doesn't print out to the console all the time. So let's upload that. We can just get rid of these, or not get rid of them. I'll comment them out because I'm going to need them in a minute. I should know how to do this by now. Control slash. Okay. Let me to remember to plug in the board. See, normally I just power the board by the micro USB cable, so I'd never plug the micro USB cable out. And I don't actually really need to plug the micro USB cable out. It is, there's a diode between the two of them, so it should be fine actually. May as well test that theory out, and so if you see any magic smoke, that was a bad choice. Okay, so there is 2 viewers on Twitch. Hello to them, and hello to all the guys on YouTube. Oops, where am I going? Cool, so this is just uploading. Okay, so done uploading. So we're going to open our serial monitor. So it's printing high, which means by default that this pin is high, and when I press it in, it's low. So, oh, interesting, it's staying low. So maybe I do need to put a pull-up with it. It's not coming back up anyways. So if I reset, it's high. It's gone low. Yep, doesn't come back up. Okay, so the other thing that we can do here is you can use something called input pull-up. So that's attaching it to a pull-up resistor. So I think what's basically happening is after the button is pressed, it's not being pulled back high again by anything. It's just floating, and it just happens to stay at low. So this input pull-up will, when it doesn't have a direct connection to ground, it's just going to pull it up. So it'll try to take the path of least resistance, so when the button is pressed, it's a direct connection to ground, but when the button's not pressed, it'll be pulled up high. Hopefully. Okay, so done uploading. So we're high there, we're low there, and we're high there. Okay, perfect. So input pull-up, very handy. It saves you having to connect a physical pull-up resistor to a pin. Okay, cool. So we'll let that just work away in the background there. So we can get rid of this delay. So what we want to do here is there is something called millis. And what that returns is basically the amount of time that has elapsed since the board started up. So what we need to do is button cooldown, button cooldown timer. Okay. Jew. That's a terrible name, but we'll come back to it. This is iteration 1. Okay, so what we want to do here is if time is greater than button cooldown due. So button cooldown due is starting at 0. Ooh, my internet got really bad there for a second. It's staying pretty bad. Come back, little internet. Uh-oh. I don't know if it's coming back up. No, it's doing something. Okay, cool. It's back. Oh, it's gone choppy again. Anyways, we'll just keep going and hopefully it sorts itself out. So if millis, so the amount of time that is elapsed, is greater than push button cooldown due. Oh, that's such a bad name. Anyways, which it will be at the start because it's 0, we can come in here and do this. So we're also going to need to look after state of the LED strip, so let's put that in there. LED strip state. So we'll start him as low. So we'll just force that here as well. So we'll do a digital, oops, doesn't matter. Okay, so what we're doing here is we're only doing this if it's due. We're doing a digital read, so it by default is high, so we want to check when it's low. That means the button has been pressed. We'll get rid of our else here. We'll do an if here, so what we're basically checking, actually we can do this as a boolean spelled correctly, false. So if LED strip state is true, which means it's on, we want to turn it off, which was these two here. What I would probably recommend doing is making a method which would be like LED strip off, but we're hacking this together. So if LED strip was on, we want to turn it off, and if it was off, we obviously want to turn it on. So we'll throw that in there. Okay. So now we need to look after the cooldown. So what we're going to do is we're going to do push bullet due cooldown due. So what we're going to do is we're going to take the current time and we're going to add 100 milliseconds to it. So that will basically tell the program, I want you to ignore whatever happens on that button for the next 100 milliseconds. And then millis, or time equals millis, will be greater than push bullet cooldown, and it'll come back in here again. So hopefully we now have a button that controls our LED strip. So let's program that up and see how we get on. Okay, well, that's programming up. Let's check Twitch. Connor has switched to Twitch. I can hear you. Yeah, is it better than YouTube? Or worse? Yeah, I keep seeing big orange lights on my OBS, so I can't imagine either of them are super good at the moment, but we do what we can. Okay, so done uploading. Let's plug in the power supply. I'm hoping this doesn't cause any issues. Okay, so it's off at the moment, which we expect. Woohoo! So press the button, it turns on. Press the button, it didn't turn back off. Oh. Yeah. It has timed out on both. Oh, that's bad. Okay, so it's pity when I was in my dad's office, like I was getting like live code reviews because the delay wasn't anywhere near as bad. I'm not setting the LED strip state, which is the problem here. So I need to do that. Yes. Yeah, I see Connor is now after saying need change state. So LED strip state was true, so now I need it to be false in here, and opposite for this. Oops. Is LEDs on? That should be my variable name, is it? Okay. Just for you, Connor, I'll change that. Okay, upload. Well, at least we knew it turned it off. And also, I was able to connect it up to 12 volts on my PC at the same time. So, I think there is a rotary encoder library. Rotary encoder library Arduino. Yes, there is. Okay, cool. It has no releases, so that means it is not on the Arduino form, or sorry, the Arduino manager. But we can, I don't even know, is this in the right format for a library? This is a repackaged version of the rotary library. Both of them seem kind of old. Doesn't necessarily mean they're bad, but I guess if I go to library, manage libraries, and search for rotary, well, that's doing that. Let's test out our LED strip here. I obviously have a I don't think I have a big enough debounce time. So like some of the times it's turning back on. Okay. Okay, let's install a rotary library over here. Encoder. Yes, let's try that out. I'll get to that in a second. So that doesn't seem to be enough time, so I'm gonna make this just for sake of arguments, I'm gonna make it 500 milliseconds. And while I'm waiting for that, I'm gonna see, does this encoder thing come with examples? And it does. So basic encoder test. Yeah, so it's saying that it works best when both pins have interrupt ability. So every pin on the ESP8266 has interrupt ability other than D0, I think. So what we might just do is test out this example on it, and then probably leave it at that, because I said I'd stream till 11, and it's 11:15 now, so I'm already overshooting. Okie dokie. Connor is asking what serial.begin. That initializes the serial connection. So nearly all the Arduinos have a built-in serial port. There's a TX and an RX pin on the thing here, but also it's connected to the USB USB to serial converter as well. So serial.begin sets the baud rate that the serial is working at. So on this example here, it's running at 9600, and in the previous one it was running at 11500, which is a lot faster, but for this it doesn't really matter because all you're doing is printing to the monitor. But in Arduino terms, it's relatively slow to do a serial print, just in comparison to other things. So you often see some people kind of saying, hey, when I put in serial debug messages, my program works fine, and when I take them out it doesn't. Just basically there's a timing issue that the serial logs or whatever are kind of hiding. So yep, that's working much better. So the other thing that's good about the way we have this kind of is push button due to be checked is you could put a delay here of 500 milliseconds, but that stops your Arduino from doing anything for those 500 milliseconds other than wait at that exact point. So like if we wanted to do something else, like listen to a different button or the rotation of the thing, or maybe even, you know, serve a web page, like you don't want to be wasting kind of clock cycles in delays if you can help it. So that's why it's much better to use millis and a due time or something like that. Yep. Okay, let's see, so what are we doing? Okay, so this worked fine. Perfect push button is working exactly as it should for that. So now let's connect up the 2 pins of the encoder and try out that library example and see does that work. I can't see why it wouldn't work, but may as well try. Okay, so just in case for anybody else that was checking, so I installed the library using include library, manage libraries, and basically nearly all libraries come with examples. So if you go to file, examples, and then examples from custom libraries, so you can see, you know, so this is my Telegram library. I've a lot of examples for it. I've actually more than that. This is an old version of that library. So encoder was the one we installed, so it comes with multiple examples. So we're going with this basic one. Seemed like as good a place to start as any. Okay, so let's power out our board and let's switch to desk. Sure, you may as well have a little picture of me in the corner. Okay, so that is DT. I don't know what that means, but we're gonna connect it in anyways. This breadboard is really bad. Okay, I got something in there. So I'm going to connect DT to D6, and then I'm going to connect what the other one is, which is clock, is it? Yeah. So I have DT connected to D6, and clock I'm going to connect to D7. Yeah, so the eventual home for this is going to be underneath my counters. Alright, thanks Connor, he has to jump off. Yeah, so the eventual home for this is going to be under my kitchen counters. So these are like waterproof LED strips, so hopefully even steam or whatever won't affect it. I don't think I'd trust this sticker to be too waterproof, but we'll stick it somehow or some way. Okay, so it doesn't really show me which pin of which. We'll just try D6 and D7 in that order. So D6 and D7. So I have 2 pins to connect, but I don't know which one is which. So I can't save that. So just gonna save it as basic encoder, and I plugged out my power as usual. Oopsies. Port 3, all good. Ooh, we had a few drops there. So Red to Fire 2 on YouTube. In my opinion, I think the whole DIY Electronics Society has slowed down. I feel like it's less active than it was back in mid-2016, specifically both on YouTube and Reddit. I'd find that pretty hard to comment on because I only really started in mid 2016. So maybe as I joined, just everybody gave up on it. Yeah, I probably wrote my first Arduino sketch, like is in just Blink, in June of 2016. So yeah, I'm not in the best position to talk. I still think there's a lot of cool stuff on YouTube. Yeah, I do sort of have a longing for more content on YouTube. Just different people, like there's some people that I watch again and again, like Great Scott is one that I nearly always check out. I think Evan Kale's videos are really entertaining. Who else is there? I think Learn Electronics does a lot of good videos too. Um, yeah, I I don't know. So I would like more for sure. I definitely would like more, but I think there's normally still good stuff on YouTube and Reddit every now and again. Um, I think if you haven't checked it out, Adafruit have a Discord that's active and really good as well. It's not just Discord or Adafruit stuff that they talk about on it, but obviously I'd imagine they would prefer if it was Adafruit stuff. But I've never seen an issue discussing any type of board on it or anything like that. I think that's good. Okay, so let's try out this thing. So I'll open my serial monitor. Yeah, I hope that answered your question. I can't really because I wasn't there before though. Okay, so I've set my baud rate to 9600, which is the same as the sketch. Okay, perfect. So I'm twisting to the right here and it's going up. Twist to the left and it's going down. Okay, perfect. So yeah, what happens if I keep twisting? Let's just go up forever. I guess so. I don't know, I must wrap at some stage. Oh, sorry, sure, you're not even looking. Sorry about that. I was just having too much fun playing with this. So, yeah. So if I twist right, the numbers go up. If I twist left, they go down. Yeah, I'm surprised that the ESP8266 isn't bigger than it is. Like when I first came across it, I was like, this thing is amazing. For $3 you get a board with built-in Wi-Fi. I couldn't believe it. Basically how I found it was I had been looking for a Raspberry Pi Zero, and there was just such a long wait time for them, or you couldn't get them. And somebody said the same thing on Reddit, basically, that we're not receiving any data, and it's back. Basically somebody was saying that like they waited so long for the Raspberry Pi Zero that they figured out what they really needed was this ESP8266, and I was like, wow, that seems so cool. So I bought one on AliExpress, and yeah, I was instantly hooked. Absolutely love it. There might be a resurgence in stuff when the ESP32 is in full kind of flow. Like at the moment, like I think the problems that the ESP32 addresses are super cool. So it has way more pins. It has more RAM, more everything. Even the fact that it has kind of cool pins like touch pins and things like that is really nice. But all that's fluff to me. Like the two things that would make me really like the ESP32 is the second processor, so you can offload tasks to the second processor, either so that can check the Wi-Fi, or it can that one can continue to check a sensor, you know. So at the moment, like with the ESP8266, like say one of my videos I built like a scrolling module of like different social media stats, and I had to be kind of clever is not the right word, but I had to be conscious about how I displayed this stuff, because when the ESP8266 is going to YouTube and getting like my subscriber stats or whatever, there's a full second there where I can't do anything else on the ESP8266, while when the ESP32 has both processors going, the second processor can look after the display and let that keep scrolling along, while the first processor goes off and gets the YouTube stats. But that second processor, it's on the hardware, but it's not supported by the Arduino IDE yet. So looking forward to getting that. And then the other one is the Bluetooth. There's a lot of just cool stuff you can do with the Bluetooth things, and at the moment that's not supported either. So once those two things are hopefully, like, I can't see why you would buy an Arduino Uno at this stage, like, unless you have a project that needs a lot of pins or a lot of analog pins. Like, every project I do, I build with an ESP8266, even if it doesn't need Wi-Fi. It's just, you know, it's small, it's cheap, it's just, I have so many of them all over the place. But yeah, I love them. I hope people continue to make cool projects with them. Yeah, cool. So I'm kind of tempted to just throw the rotary encoder stuff in and see how we get on. Yeah, sure, why not? I'll give it 5 minutes. Okay, so let's pull in this encoder H and also this into my example. So what I'm just going to do is, if that position is going up, I'm going to just increase a number, and if it's going down, I will decrease that number. Okay, old position. Let's take this. Probably should have a better name than Blink, but anyways. Okay, cool. So that's that, and I need my old position. I also need more than that. Sorry, I feel like I went on a bit of a rant about the ESP8266 there. Okie dokie, so old position, we'll keep that, and now let's keep a count. So let's start the brightness. Let's start it at 200. Okay, so let's do this. Right, let's only read the rotary encoder when the LED is on. So move that up there. Now, if waiting on some to ship in from the US. This was a cool stream. Gotta go cram for accounting now. Cool. Thanks for joining Red 2 Fire 2, and good luck with the accounting. Okay, so cool. Let's do this. If new position is greater than old position, let's increase brightness by brightness is equal to brightness plus, let's do it properly, brightness plus equals 10, and then if brightness is greater than 102, 1023. We'll just let it equals 1023. And let's do the same with... Okay, so if it's not that, I suppose I better check that they're not the same. Else, if... I guess there's some scenario where they could come back as the same. And I don't want to be changing the brightness of the light based on that. So if new position is less than old position... Oh, I'm so used to IDEs that finish your curly braces. So we're going to do the same thing as here, except we're going to do -10. Yeah, I guess I'm kind of in a weird position here that if it's greater than 1023, I might just make that 0, so, or 1020, so it's an even number. Excuse me. So if, let's do if this is less than 0, I suppose I better change the one that actually matters. Okay, so that's just basically protecting. We're going to do an analog write here, so it's just protecting that the analog write is that the analog write is within bounds. And we also need to change this to use brightness instead, and we can get rid of this. So let's do Control T does a format in Arduino, so that looks a bit better. Let's give it a go. Brightness is not declared in the scope. Bright. Yes, I can't spell. Whoops. I also missed that in proper IDEs as well. Oh my god. Like, why is it waiting till I compile to tell me that I've spelled brightness wrong in a million places? Yeah, so that should be that. Okay. Hello to the 5 people on YouTube and 2 people on Twitch. Yeah, I didn't advertise the stream at all, mainly because I didn't know how the quality would hold up. It seems to have struggled a little bit, so I will maybe drop the quality down a tiny bit. I think it should be still okay to see and stuff. Okay, so that's done uploading. So anyone want to take any bets if this will work or not? Okay, so the first thing we want to check is that turn this on, turns it on. Okay, now that doesn't seem to be doing anything. Oops. Twisting has not done anything, so maybe I should be serial printing. Or maybe there's something else I've missed. So if LED is on, I want to analog write brightness. Brightness should change if LED is on. Yeah. That looks okay. Maybe I'm missing something, am I? No, don't see anything missing. Do I need to analog write 0 to write a new analog brightness? Let's put this in and see how we get on with that. See, there's the position change. Do you know what I'll do is I'll put in a stop it. So I'm doing a new compile here. It's complaining that I can't open port 3, probably because it was already open. No, stop. Oh, it's not happy with me at all at the moment. Okay, building again. So I've just added a serial print on new position and on brightness, so we should see that change the same as we did before if it goes up. All cool. Oh. Whew, silly me. I never assign new position to be old position. New position. Oh, other way around. Old position equals new position. Let's upload again. Getting pretty tired now, so be finishing as soon as this is done, hopefully. Okay, done uploading. Let's test that this works. That works. Okay. Okay, cool. It's working the way we want it to now. So we can turn it down all the way to off, and so that's as low as it goes. That should be like 10. Oh, I have the wrong baud rate. And it's printing all the time. Oops. Interesting. So it's 40. So that's 0. That's 10. Okay, 40. So it seems to jump a lot. So you nearly want to make it go less than that. So every twist to the dial seems to be nearly 40. Yeah, it's 40 every twist, so I suppose it's not bad. So that's as dim as it goes, and then we can crank it up. It's actually, no, it feels pretty good. Okay, cool. So to recap, we took a 12 volt LED strip. We took a 12 volt power supply over here. I can't pull it far enough. We converted the 12 volts to 5 volts to connect it to our ESP8266 using a DC to DC converter. These are really cheap on AliExpress. I'll probably update the video description afterwards on YouTube. When it goes up, it'll probably be tomorrow. So we're using that to convert the 12 volts to 5 volts so we can use the same power supply. We're using an IRLB8721 MOSFET to control the power. Using the ESP8266, so that's connected to the ground pin of the LED strip. And then we're using a rotary encoder to change the brightness of the LED strip and also to push the button to turn it on and off. So I'll probably continue this project in another stream. I want to add a web page to the ESP8266 so I can control this. And also I would like to add Alexa control as well. So I can say like, Alexa, turn the LED strip on. Might give it a cooler name than LED strip. we should be able to also say things like Alexa, turn half brightness on. That would be like another object called half brightness. So yeah, we'll see how that goes on. Okay, so for anybody who's left, thanks a lot for joining in, and I'll see you next time. Okay, thanks guys.